Introduction to Azure. Welcome to this audiobook on Azure, Microsoft's cloud computing platform. Whether you're an aspiring cloud engineer, a developer, or simply curious about cloud technologies, this book will give you a strong foundation. Azure offers a wide array of services, from hosting websites to running artificial intelligence models. Let's begin our journey into the cloud. What is cloud computing? Cloud computing is the on-demand availability of computing resources over the internet. Instead of owning servers or data centers, users rent computing power, storage, and services as needed. Azure, like Amazon Web Services and Google Cloud, is a major player in this domain. With cloud computing, businesses gain flexibility, scalability, and cost efficiency. The origins of Microsoft Azure. Microsoft Azure was officially launched in 2010 under the name Windows Azure. It began as a platform as a service offering and gradually evolved into a full-fledged cloud platform. Today, Azure supports over 200 products and cloud services, serving millions of customers around the world. Azure Global Infrastructure. Azure's infrastructure spans a massive global network. With data centers in more than 60 regions, Azure ensures that services are available, resilient, and close to users. These regions are paired for disaster recovery, and each region contains multiple data centers with state-of-the-art physical and network security. Core Azure services. At the heart of Azure are its core services: compute, networking, storage, and databases. Azure Compute allows you to run virtual machines, containers, and serverless applications. Azure Storage provides scalable, durable data storage solutions. Networking services like Azure Virtual Network and Azure Load Balancer help you build secure and connected systems. Meanwhile, Azure offers databases such as SQL Database, Cosmos DB, and more. Understanding Azure Resource Manager. Azure Resource Manager, or ARM, is the deployment and management service for Azure. It lets you organize resources like virtual machines, storage accounts, and networks into resource groups. You can define and deploy infrastructure using templates, making your cloud environment consistent and repeatable. Azure Portal and Tools. Azure provides several tools to manage resources. The Azure Portal is a web-based user interface for building, managing, and monitoring services. For developers and power users, Azure CLI and PowerShell offer command line access. You can also use tools like Visual Studio, Azure DevOps, and Bicep for infrastructure as code. Security and compliance in Azure. Security is a top priority in Azure. It offers features like Azure Active Directory for identity management, Key Vault for secrets and certificates, and Security Center for threat detection. Azure also complies with a wide range of global standards and regulations, making it a trusted platform for governments, healthcare providers, and enterprises. Azure Pricing and Cost Management. Azure operates on a pay-as-you-go pricing model. You only pay for what you use, with no upfront costs. Azure also offers calculators and budgeting tools to help you estimate costs and manage your cloud spending. Additionally, reserved instances and spot pricing help optimize cost efficiency for predictable workloads. Use cases of Azure in real life. From startups to Fortune 500 companies, organizations use Azure for a variety of purposes. Some run websites and mobile apps. Others use it for big data analytics, artificial intelligence, or disaster recovery. With its hybrid capabilities, Azure integrates well with on-premises systems, making it a great choice for businesses in transition. Azure Virtual Machines. Azure Virtual Machines, or VMs, are one of the most fundamental services on the platform. They allow you to run full operating systems, Windows or Linux, on the cloud. You can scale up or down as needed, choose from a variety of sizes and configurations, and even use pre-built images for faster setup. Azure VMs are ideal for applications that require full control over the environment or that cannot easily be containerized. Azure App Service. Azure App Service is a platform as a service offering that lets you quickly build, deploy, and scale web applications and APIs. It supports .NET, Java, Node.js, Python, and more. App Service handles the infrastructure for you, things like patching, load balancing, and autoscaling, so you can focus on writing code. It's an excellent choice for web developers who want rapid deployment without managing virtual machines. Azure Functions. Azure Functions is a serverless compute service that enables you to run small pieces of code without worrying about infrastructure. You write a function, define a trigger, like an HTTP request, a timer, or a message from a queue, and Azure takes care of the rest. Functions are great for automating tasks, responding to events, or building microservices. You only pay for the compute time your code actually uses. Azure Logic Apps. Azure Logic Apps let you automate workflows without writing code. You can design flows using a visual designer, connecting hundreds of services including Office 365, Salesforce, GitHub, and Azure services. For example, you can create a logic app that listens for new emails, extracts attachments, and stores them in a SharePoint folder. It's a powerful way to integrate systems and streamline business processes. Azure Kubernetes Service. Azure Kubernetes Service, or AKS, is a managed Kubernetes solution that simplifies container orchestration. Kubernetes is the de facto standard for running containers at scale, and AKS makes it easier by handling tasks like cluster setup, upgrades, and scaling. It integrates tightly with Azure Monitor, Azure DevOps, and other tools, giving you full control over your containerized applications while reducing operational complexity. Azure DevOps. Azure DevOps is a suite of development tools that help you plan, develop, deliver, and maintain software. It includes services for version control, continuous integration and delivery, artifact storage, test management, and project tracking. Whether you're deploying a simple website or managing a global software release pipeline, Azure DevOps supports agile workflows and enhances collaboration across development teams. Azure Cognitive Services. Azure Cognitive Services provide ready-made AI capabilities that you can integrate into your apps with minimal effort. These services cover areas like vision, speech, language, and decision-making. For instance, you can add facial recognition to your app, translate text in real time, or analyze sentiment in customer feedback. The APIs are easy to use and designed to democratize artificial intelligence. Azure Machine Learning. Azure Machine Learning is a cloud-based platform for building, training, and deploying machine learning models. It supports Python, R, and popular frameworks like TensorFlow and PyTorch. You can use the Visual Designer for drag-and-drop model creation or write custom code in notebooks. With features like automated ML, experiment tracking, and model monitoring, Azure ML simplifies the end-to-end machine learning lifecycle. Azure Synapse Analytics. Azure Synapse Analytics is a powerful analytics service that combines data warehousing and big data analytics. You can query data using either SQL or Spark, integrate with Power BI for visualization, and analyze massive volumes of data in real time. It's designed for enterprises that want to gain insights from structured and unstructured data at scale. Azure Monitor and Application Insights. Monitoring is critical in cloud environments, and Azure offers robust tools for observability. Azure Monitor provides metrics, logs, and alerts for your infrastructure and applications. Application Insights, a feature within Azure Monitor, helps you detect issues, analyze performance, and understand user behavior in web apps. These tools help keep your systems healthy and responsive. Azure Active Directory. Azure Active Directory, often abbreviated as Azure AD, is Microsoft's cloud-based identity and access management service. It helps organizations manage users, devices, and access to applications. With Azure AD, you can enable single sign-on, enforce multi-factor authentication, and define role-based access control. It's used by millions of organizations to secure user identities and simplify login experiences. Azure AD also integrates with thousands of third-party apps and is a central part of Microsoft 365 security. Hybrid Cloud with Azure Arc. Azure Arc extends the Azure platform beyond Microsoft's own data centers. With Arc, you can manage and govern resources across on-premises environments, multi-cloud setups, and the edge. For example, you can apply Azure policies to a Kubernetes cluster running in your own data center, or monitor a SQL server that lives in another cloud provider. Azure Arc is all about hybrid flexibility, bringing Azure's management tools to wherever your workloads run. Azure Site Recovery. Business continuity and disaster recovery are essential for any enterprise. Azure Site Recovery is a service that replicates your on-premises or cloud-based virtual machines and keeps them in sync with a backup region. In the event of a failure, you can fail over to the replicated site with minimal downtime. Once the issue is resolved, you can fail back to the original location. It's a key part of an organization's resilience plan. Azure Backup. In addition to recovery solutions, Azure provides powerful backup services. Azure Backup is a scalable and secure way to protect your data, whether it's virtual machines, SQL Server databases, or files. It uses encryption in transit and at rest, and it retains data according to policies you define. With centralized management, automated backups, and instant restores, it's a must-have for critical workloads. Cost optimization best practices. Managing cost in the cloud is just as important as managing performance. Azure provides a number of tools and strategies to help you stay within budget. Azure Cost Management and Billing lets you analyze spending, set budgets, and track usage across subscriptions. You can reduce costs by using reserved instances for predictable workloads, shutting down idle resources, and optimizing VM sizes. Monitoring tools can also help identify underutilized resources. Being proactive with cost optimization ensures you're getting the most value from your cloud investment. Azure policy and governance. As cloud environments grow, governance becomes critical. Azure Policy is a service that helps enforce rules and ensure compliance across your environment. For instance, you can require that all storage accounts are encrypted or that only certain regions are used for resource deployment. Combined with Azure Blueprints, which define resource configurations and permissions, Azure Policy helps maintain consistency and control at scale. Azure Marketplace and third-party integration. The Azure Marketplace is an online store for software applications and services certified to run on Azure. You can find virtual appliances, machine learning models, development tools, and entire solution stacks ready to deploy. Marketplace offerings come from Microsoft as well as third-party vendors, and many include free trials or bring your own license options. This makes it easy to integrate trusted solutions into your cloud ecosystem. Sustainability and green cloud computing. Microsoft is committed to sustainability, and Azure reflects that mission. The platform is powered increasingly by renewable energy, and Microsoft has pledged to become carbon negative by 2030. Azure's data centers are designed for energy efficiency and environmental responsibility. For businesses that prioritize eco-conscious operations, Azure provides tools to measure and reduce carbon impact associated with cloud usage. Real-world Azure architecture examples. To understand Azure in action, it helps to look at how real companies use the platform. Consider a global e-commerce company. They may use Azure App Service to host their website, Azure SQL Database to store customer data, Azure CDN to deliver content quickly around the world, and Azure Cosmos DB to handle massive amounts of product information with low latency. Behind the scenes, Azure Monitor and Application Insights track performance, while Azure DevOps ensures smooth deployment of new features. Another example is a hospital system using Azure Machine Learning to predict patient readmissions, storing records in secure storage, and enabling clinicians to access dashboards through Power BI. These architectures are scalable, secure, and reliable, and Azure makes it possible. C/CD pipelines on Azure. Continuous integration and continuous delivery, known as C/CD, are core practices in modern software development. Azure DevOps and GitHub Actions enable developers to automate code testing, building, and deployment. For example, a team might push code to a GitHub repository, trigger a pipeline that runs unit tests, builds a Docker image, and deploys the app to an Azure Kubernetes service cluster. Along the way, environment variables, secrets, and approvals can be managed through built-in policies. These pipelines speed up development and reduce human error, ensuring that new features reach users safely and quickly. Networking in Azure. Networking is the backbone of every cloud application. Azure provides a range of services to connect and secure workloads. Azure Virtual Network, or VNet, lets you build private networks in the cloud. You can configure subnets, route tables, and network security groups to control traffic. Azure Load Balancer and Application Gateway distribute traffic across instances and manage routing based on conditions like URL paths. Azure DNS handles domain name resolution, while services like Azure Bastion and VPN Gateway provide secure access to resources. For global traffic, Azure Front Door and Azure Traffic Manager ensure that users connect to the nearest and fastest endpoint. Azure Certifications and Career Paths. If you're looking to build a career in cloud computing, Azure certifications can open doors. Microsoft offers role-based certifications for developers, administrators, architects, security engineers, data scientists, and more. Popular certifications include Azure Fundamentals for Beginners, Azure Administrator Associate for infrastructure roles, and Azure Solutions Architect Expert for advanced design skills. Preparing for these exams helps build deep technical knowledge and proves your skills to employers. Whether you're starting fresh or advancing in your IT career, Azure certifications are a valuable investment. Migrating to Azure. Many businesses are moving their existing workloads to the cloud, and Azure provides tools to make migration smooth. Azure Migrate is a centralized hub for discovering, assessing, and moving resources. It supports migrations from VMware, Hyper-V, physical servers, and other cloud providers. You can rehost virtual machines, refactor apps to use cloud-native services, or fully rebuild systems for a modern architecture. The goal is to reduce downtime and minimize disruption while improving performance and scalability. Building resilient applications in Azure. Cloud-native applications need to be designed for failure. Azure supports high availability through availability zones, region pairs, and redundancy options for storage and databases. Developers can build resilience into their apps using retry policies, circuit breakers, and load balancing. Azure also provides chaos engineering tools through services like Azure Chaos Studio, helping teams test how systems behave under failure conditions. By planning for failure, you build applications that can recover quickly and keep users satisfied. The future of Azure. Azure continues to evolve with advancements in artificial intelligence, quantum computing, and edge computing. New services and improvements are constantly being added, pushing the boundaries of what's possible in the cloud. As businesses demand more innovation, Azure's flexibility and scale position it as a leading platform for the future of technology. Creating and deploying a simple Node.js app on Azure. Let's walk through the steps to create and deploy a simple Node.js application on Azure. This process involves building your app, setting up your Azure environment, and publishing your application to the cloud. Start by creating a basic Node.js application on your local machine. This typically includes initializing a project, installing necessary packages, and writing your server logic. You'll also want to test the app locally to make sure it runs as expected. Next, prepare your code for deployment. This means organizing your project files, ensuring your dependencies are listed properly, and including configuration files that Azure will use to understand how to run your app. This may include setting a start script and environment variables. After that, you'll need to set up your Azure account and log in to the Azure portal. From there, create a new app service. This service is designed to host web applications and APIs with minimal setup. Choose Node.js as the runtime stack, select a region close to your users, and decide on the pricing plan that suits your needs. Once the app service is created, you can deploy your Node.js app using a method of your choice. Common options include pushing code directly from your local machine using Git or the Azure CLI, connecting your app to a GitHub repository for continuous deployment, or using Visual Studio Code's built-in Azure extension for a more visual deployment experience. After deployment, test your application in the cloud by visiting the URL provided by Azure. You should see your Node.js app running live. You can then monitor its performance, configure scaling options, and set up custom domains or HTTPS through the Azure portal. This process gives developers a fast and flexible way to take their Node.js applications from development to production with minimal friction. Azure handles the infrastructure, so you can focus on building features and delivering value. Monitoring and scaling your Node.js app on Azure. Once your Node.js application is deployed on Azure, it's important to keep an eye on how it's performing and make sure it can handle traffic as your user base grows. Azure provides powerful tools to help with both monitoring and scaling. To monitor your application, start with Azure Monitor and Application Insights. Azure Monitor gives you a high-level view of the health and performance of your resources. You can track CPU usage, memory consumption, response times, and error rates. With Application Insights, you get deeper visibility into how your app behaves. It can automatically detect performance issues, capture exceptions, and even track user interactions. You can visualize this data through dashboards, set up alerts for specific thresholds, and use it to troubleshoot problems in real time. Application Insights also supports live metric streaming. This means you can watch your app's activity as it happens, requests per second, server response times, and failure rates, all in a live view. This is especially useful during deployments or when debugging issues. Now, let's talk about scaling. Azure App Service makes it easy to scale your app both manually and automatically. You can increase the number of instances your app runs on with just a few clicks. This is called horizontal scaling. It adds more copies of your app to handle more traffic. You can also use vertical scaling, which means upgrading your existing instance to a more powerful one with more CPU and memory. Automatic scaling, or autoscale, allows Azure to adjust the number of instances based on real-time conditions. For example, you can set a rule that says, if CPU usage goes above 70% for more than 5 minutes, add another instance. When traffic slows down, Azure will scale back down to save costs. This makes your app more resilient and efficient, especially when traffic patterns are unpredictable. Monitoring and scaling go hand in hand. By understanding how your app performs and configuring it to respond to changes in demand, you ensure a smooth experience for users while optimizing your resource usage. Securing your Node.js app on Azure. Security is a top priority when hosting applications in the cloud, and Azure offers many built-in features to help you protect your Node.js app. The first layer of protection is enabling HTTPS. Azure App Service supports free SSL certificates, allowing you to encrypt traffic between your users and your app. This ensures that sensitive data, like passwords or personal details, isn't exposed in transit. Next, consider authentication and authorization. Azure App Service makes it easy to integrate with identity providers such as Microsoft, Google, Facebook, or even enterprise systems using Azure Active Directory. You can require users to sign in before accessing your app and assign different permissions based on their identity. You should also secure your app's environment. Store secrets, like API keys, database passwords, or tokens, using Azure Key Vault. This service securely manages sensitive information and integrates directly with App Service, so your secrets don't need to be hard-coded into your codebase or configuration files. To protect against threats, enable Azure Defender for App Service. It scans your application for vulnerabilities, checks your configurations, and alerts you if something seems off. It can also detect unusual activity, like unexpected requests or changes in behavior, which might indicate an attack. Finally, use firewall rules, IP restrictions, and access controls to lock down who can connect to your app and its resources. Combine these features with monitoring and logging to create a strong, proactive security posture. Adding Azure SQL Database to your Node.js app. Most web applications need a database, and Azure SQL is a reliable, scalable choice for storing structured data. It's a fully managed relational database built on Microsoft SQL Server, designed for performance, security, and availability. To begin, create a new Azure SQL database through the Azure portal. You'll choose a logical server, set your pricing tier, and configure options like geo-redundancy and backup policies. Once the database is ready, configure firewall rules to allow your Node.js app to connect securely. From your application's environment, store your database credentials securely using App Service Application Settings or Key Vault. These values, like the server address, username, and password, can be referenced by your app during runtime. In your Node.js app, use a database driver or ORM like Tedious or SQLize to establish a connection with the Azure SQL database. You can then perform typical operations like inserting records, querying data, and managing relationships, just like with any SQL database. Azure SQL also includes built-in performance tuning, threat detection, and automatic patching, reducing the operational overhead. As your app scales, your database can scale too, vertically by upgrading compute power, or horizontally by using features like read replicas or elastic pools. Together, securing your app and integrating it with Azure SQL forms the foundation of a production-grade cloud application, resilient, responsive, and ready for real-world use.